This discussion happened in a lecture about the weirdness of the rules for when an implication is true, and we came up with a good way to talk about it, so I wanted to share. So here we're talking about something like P implies Q. In this case, we call P the assumption and Q the conclusion. Recall that by definition, this implication is true in 3 cases, but false in only 1 case, when the assumption is true, but the conclusion is false. And a lot of people find it weird about how this rule gives us a truth value when the assumption is false. But let's think about it this way. Let's say I have a personal rule that I never ever break. It's ironclad. If it is raining, then I take an umbrella. That's it. Here P is it is raining, and Q is I take an umbrella. What this rule is good for is that you can always be confident that if you see rain falling from the sky, that when you run into me, you will see me with an umbrella. Okay, now let's say it's a sunny day. Does that mean I have an umbrella? Well, who knows? My rule only applies when it is raining. If it is a sunny day, then I can do whatever I want, and I haven't broken my rule. The rule is irrelevant to the situation, and we say that the rule will hold. Let's think of a more mathematical example. Here's a theorem. If x is a real number, then x squared is greater than or equal to 0. This is always true. Plug in any x that's a real number, and you will get a non-negative number when you square it. But then, what do you say? Okay, what if x is not a number? What if x is a cat? Right? Clearly, this isn't relevant to my theorem, so it's still true. The theorem is still true. Surely we can't say, well, if x is a cat, then the theorem has to tell us something. It just doesn't tell us anything. But it's still true. Anyway, just wanted to put that short explanation out there, and I hope it helps clarify some ideas for everyone.